Dus thing 1, 2. Okay, let's read this. Writing an efficient Vulkan renderer. I'll read this answer. You can, but don't have to. Benefits can be using multiple threads to record. Or just convenience. Hey, Retin. I asked on the Vulkan Discord, would one typically submit a single command buffer per frame? Or is there a benefit to submit multiple command buffers for a single frame? And one guy says, you can but don't have to. That's not an answer. Benefits can be using multiple threads to record. I didn't ask about recording it. I want to know about submitting. But okay, he's right, of course. If you want to use multiple threads to record it, then you end up with multiple command buffers. Then you have to submit them separately. So he says benefits can be using multiple threads to record if you have very large command buffers. Or just convenience. Well, we don't go with that, right? Someone else says make as few command buffers as possible. You're forced to use multiple for various reasons as you want to fully exploit Vulkan. For example, parallel command recording or multi-queue require you to make multiple per frame. No way around that. So it's absolutely possible to just submit one. Okay. And then the first guy says again, oh yeah, but performance-wise, the thing you definitely want to avoid is doing too many submits. Well, you can submit multiple command buffers in one submit. Multiple submits can also increase performance, but that's tricky. And sometimes are required. Inter-queue sync only works between submits, for example, sadly. Yeah, ask away. Well, as usual, I don't understand the question. Is it possible change using type alias in runtime? It's not even English. Can you formulate it in a way that it makes sense? These guys keep on talking. I'm gonna read this. So this guy says, I wrote an article, wide range of topics. At the time of publishing this article, the Kindle edition of the book is available for $3 on Amazon. Well, maybe you should buy that. This, however, is the full, free of charge copy of the article. So what's the difference then? I don't think I ever used standard conditional. Don't know what it is. Vulkan is a new explicit cross platform. It introduces many concepts that may be unfamiliar to seasoned graphic programmers. The key call of Vulkan is performance. However, attaining good performance requires in-depth knowledge about these concepts and how to apply them efficiently, as well as how particular driver implementations implement these. This article will explore topics such as memory allocation, descriptor set management, command buffer recording, pipeline barriers, render passes, and discuss ways to optimize CPU and GPU performance of production desktop / mobile Vulkan renderers today, as well as look at what a future looking Vulkan renderer could do differently. Modern renderers are becoming increasingly complex. Oh really? Must support many different graphics APIs with varying levels of hardware abstraction, disjoint sets of concepts. This sometimes makes it a challenge to support all platforms at the same level of efficiency. I wouldn't call this an abstract. It's more like an introduction. not an abstract at all. Fortunately, for most tasks, Vulkan provides multiple options that can be as simple as re-implementing concepts from other APIs with higher efficiency due to targeting the code specifically towards the renderer needs. And as hard as redesigning large systems to make them optimal for Vulkan, we will try to cover both extremes when applicable. Ultimately, that is a trade-off between maximum efficiency on Vulkan-capable systems and implementations and maintenance costs that every single engine needs to carefully pick. Additionally, efficiency is often application dependent. The guidance in this article is generic, and ultimately best performance is achieved by providing the target application on a target platform and make an informed implementation decision based on the results. This article assumes the reader is familiar with the basics of Vulkan API and would like to understand them better and or learn how to use the API efficiently. Yeah, totally. Introduction. So, memory management. I'm using VMA already. I'm not going to read this at the moment. Descriptor sets. Well, I've been working for the last month at least, if not longer, on descriptor sets. So let's not read that. Slot-based binding. I guess that's what I did. Vulkan specification only guarantees a minimum of 4 descriptor sets. Whoa, yeah. I didn't implement this yet. I don't know. I don't think I have any provision for using different descriptor sets in different stages. Don't allocate or update descriptor sets if nothing in the set changed. I'm not. In a model with slots that are shared between different stages, this can mean that if no textures are set between two draw calls, you don't need to allocate or update the descriptor set with texture descriptors. Hello, Bear. Batch calls to VK allocate descriptor sets. If possible, some driver, each call has measurable overhead, so if you need to update multiple sets, allocating both in one call can be faster. To update descriptor sets, either use VK update descriptor sets with descriptor set array. Sorry, with descriptor write array. Or I use with templates. Yeah, this looks like it's all like 50 times more complex than what I did so far. It's no fun. Descriptor templates can reduce the amount of work application needs to do to perform updates, since in the scheme you need to read descriptor information out of shadow state maintained by application. Descriptor templates allow you to tell the driver the layout of your shadow state, making updates substantially faster on some drivers. Right. Oh boy. Finally, prefer dynamic uniform buffers to update uniform buffer descriptors. Uh-oh. I'm not even sure what dynamic means here. Does it mean that I can change it every frame? That's what I'm doing, but not calling it dynamic uniform buffers. And I guess it has to do with this thing, which I'm not using. On mobile hardware, it may make sense to cache descriptor sets based on the descriptors they contain, if they can be used later in the frame. Well, that's what I'm already doing, but I'm on a high-end PC. Frequency-based descriptor sets. Well, this is still about descriptor sets. I don't want to go back there until, you know, I'm much, much further and I have reason to believe that it can be optimized. For now, mostly interested in making the interface easier to use. And then not in a super naive, inefficient way. And I don't think I did that, but well, you never know. Anyway, if that's the case, then I should run into it at some point. I should have read this before I started my implementation of the descriptor sets. It's a good article. I'm going to scroll down. Bindless descriptor designs, yeah, those are even better. I'm not doing that either. Material data, I probably have to read everything here, but what I'm really currently mostly interested in is this command buffer recording. Let's read that. Because this is what I'm going to work on next. And well, no, then it's a good thing that now I'm reading it before I start working on it. In older APIs, there is a single timeline for GPU commands. Commands executed on the CPU execute on the GPU in the same order, as there are as there is generally only one thread recording them. There is no precise control over when CPU submits commands to the GPU, and the driver is expected to manage memory used by the command stream as well as submission points optimally. I'm not sure if rereading that will make me understand it. That has to do with the driver runs the CPU side? Yeah, I guess so. So you have an API for the old, say, OpenGL, and then it's not being submitted to the GPU at your own control. It happens at some point, but it's apparently something that runs on the CPU that decides that. Well, in Vulkan, you definitely do submit yourself, so you know exactly when that is being done. In contrast, in Vulkan, the application is responsible for managing command buffer memory recording commands in multiple threads into multiple command buffers and submitting them for execution with appropriate granularity. While with careful written code, a single core Vulkan renderer can be significantly faster than older APIs. The peak efficiency and minimal latency is obtained by utilizing many cores in the system for command recording, which requires careful memory management. One of the things that I do not know or understand is that what is so slow about it that you need multiple threads to record it? Is it the recording or is it just submission of a command buffer? Or does submission not take time? I have absolutely no idea about the timings that hopefully he is going to explain this. Similarly to descriptor sets, command buffers are allocated out of command pools. It's valuable to understand how a driver might implement this to be able to reason about the costs and usage implications. Command pool has to manage memory that will be filled with commands by CPU and subsequently read by the GPU command processor. The amount of memory used by the commands can't be statically determined. A typical implementation of a pool would involve thus a free list of fixed size pages. Command buffer would contain a list of pages with actual commands with special jump commands that transfer control from each page to the next one so that GPU can execute all of them in sequence. No idea where he gets the jump commands from. I mean, is it just it sounds like, okay, you need to allocate stuff to record your commands, but okay, and that is not all sequential, or what's a better word, contiguous. So you just have a linked list of memory blocks, meaning that you have simply a pointer to the next block. So why call that pointer a command? But okay. Whenever a command needs to be allocated from a command buffer, from a command buffer. Yeah. Either he means from a command pool, or he means that the new command that is being recorded to a command buffer requires new allocation. It will be encoded into the current page. If the current page doesn't have space, the driver would allocate the next page using a free list from the associated pool, encode a jump to that page into the current page and switch to the next page for subsequent command recording. Okay, whatever. Each command pool can only be used from one thread concurrently. I knew that. So the operations above don't need to be thread safe. Freeing the command buffer using VK free command buffers may return the pages used by the command buffer into the pool by adding them to the free list. Resetting the command pool may put all pages used by all command buffers into the pool free list. When VK command pool reset release resources bit is used, the pages can be returned to the system so that other pools can reuse them. When that is being used, then that is possible. If you do this means if you do a reset, then we release the resources. Note that there is no guarantee that VK free command buffers actually returns memory to the pool. Alternative designs may involve multiple command buffers allocating chunks within larger pages, which would make it hard for VK free command buffers to recycle memory. Indeed, on one mobile vendor, VK reset command pool is necessary to reuse memory for future command recording in a default setup when pools are allocated without that bit. Yeah, okay. Should I look at my own code? I don't think so. I think I'm using one pool per thread. No, I'm using one pool per task, but that's the same thing. Multi-threaded command recording. Two crucial restrictions in Vulkan for command pool usage are command buffers allocated from one pool may not be recorded concurrently by multiple threads. Thank God I knew that. Command buffers and pools cannot be freed or reset while GPU is executing the associated commands. That's why we have. That's why my command buffers are part of my frame resources. Because of these, a typical threading setup requires a set of command buffer pools. The set has to contain F times T pools, or F is the frame queue length. What? F is usually 2. Oh, okay. I think that's what I call frame resources. Maybe frame queue is a better name then. Got the frame resources from this Intel tutorial thing. And yeah, it was never really that clear. A name, I think. F is usually 2. One frame is recorded by the CPU while the other frame is being executed by the CPU. Well, either that or 3. T is the number of threads that can concurrently record commands, which can be as high as the core count on the system. Well, isn't it so that a core can execute with hyperthreading, like 2 threads? When recording commands from a thread, the thread needs to allocate a command buffer using the pool associated with the current frame and thread and record commands into it. Yeah, so currently I'm having a command pool that I get from the frame resources. Let's look at my code. Like here, this is in the inside of the render loop. Just before we start recording, I mean, it is just before we start recording the command buffer, but it's still inside a render loop. It's not even in a different thread. And while being inside a render loop, I have frame resources, which this guy calls a frame queue, I guess. And so every other frame I switch to another set of frame resources, or every 3 frames, you know, just if I have 3 of them. In fact, I say 2 and 3 because that's what they said. In my case, it's dynamic. I can do whatever I want. But 2 or 3 is probably optimal, or there's no need to have more than that. Anyway, we have a current frame resource, and that has a single command buffer, and that's what I'm using. And then the next frame, you enter from the top here, and then I get, there's a different frame resource, so I get a different command buffer. And then the next frame, we might get the first one again, etc. But if this was if there was a task that, if there were multiple tasks that were recording command buffers, well, then I guess that instead of getting the command buffer here, I would get I would get access here to the task. No, that's not true, of course. The task is run somewhere. I would access the fully recorded command buffer. Buffers from the multiple tasks that are recording my command buffers. Let's say I have 13 tasks that are all recording command buffers in parallel, and I get here, and then I need to get the results if they are finished already. So I would have 13 command buffers here, and then I need, they are already recorded, so I just need to submit them, and I can submit them all in one call. Submit can submit multiple command buffers is possible. At that point, GPU is executing those command buffers. So then the next time that we get here, from the top of the render loop, you cannot use the same command buffer. So the fact that this command buffer is now being submitted, being rendered, is something that has to be communicated to the tasks that are recording to it. They may not record to it. At that point, they have to record to another command buffer. Yeah, well. It's basic, guys, it's basic. I'm hiding the line numbers, but that's just me. If I would click on F8, and you can get to see all the line numbers. Just reacting to the chat. Okay, so yeah. So kind of the task of this draw frame, which is part of the render loop, which is a member function of the window, is to get recorded frame buffers, recorded command buffers, and submit them. This will be replaced by getting a recorded command buffer, a fully recorded command buffer. And then all of this is not needed, because this is code that records it. Not sure to do with IMGU. And IMGU is literally immediate. The IM stands for immediate, which kind of means that we want to do it right here. So I might want to keep it here. It's I'm using IMGU as one should. That is just for debugging. It's not performance critical. Plus it is pretty damn fast anyway. However, if the debugging interface is turned on, like though this is being defined here, enable IMGU, then we are recording another render pass. Those 3 lines are the IMGU thing. So we do need a command buffer. A command buffer that was not ended yet. We did not call end on it yet. But I guess that could easily be arranged. I'm getting maybe multiple command buffers, but I'll just, instruct the tasks that record the command buffers to not execute this final end, I guess. Or if this call to, I'm not sure. I don't think this call to end is doing something special, right? I mean, it's not going to be, it's not going to cost me a lot of CPU to do this end call. So assuming that's not the case, then I can just append the IMGU stuff to one of the command buffers, and then we submit all of them. Let's continue reading. So I have a number of threads or tasks, and then each task is responsible for keeping the frame queue length number of command buffers. But I do have to communicate with the tasks which command buffer they are allowed to record to. Somewhere there must be some kind of synchronization. Otherwise, there is the danger that I would be recording to a command buffer that is still being displayed. Where was I? When recording commands from a thread, the thread needs to allocate a command with using the recording commands into it, assuming that command buffers aren't recorded across a frame boundary. Oh, well, yeah. That is a thing, isn't it? It might happen. Is that a reasonable assumption? I mean, if if this was not true, then you would get a lot of latency. I mean, if you start recording a command buffer, you already know how the scene looks like, right? I think. Yeah, probably, yeah. Immediately after recording the command buffer, it might be submitted. And as soon as you submit it, all the data involved in the rendering that is using that command buffer is not allowed to be changed. It must be static, constant. So we cannot record a command buffer and then make changes to it later. Therefore, if we record a command buffer and then we go across a frame boundary, so let's exaggerate it, we're going multiple frame boundaries, then we have recorded the command buffer which depicts how a scene looks like. And then only several frames later you get to see it. So that's, of course, well, that's latency. We don't want that. Also interesting is if I have multiple threads that do this, or tasks, and really you want, of course, I mean, each command buffer is going to be something visible, likely, in the scene. And then if there is if we go over a frame boundary due to it taking too long to record or whatever, then there might be a difference between one recording and another. So then only a part of the frame would be lagging. Say you have I have certain scene where in two objects or maybe even physics is happening, and you're recording different objects with different command buffers, and one of them lags longer than the other, then you get to see in one frame things that do not belong in the same time, in the same point in time. And that's probably also not what you want. Things kind of have to be synchronized per frame. Okay, I think that if at all possible, you don't want this to happen. If it does happen, then probably what you want to aim for is use even more threads, and get it done within one frame. Okay, assuming that command buffers are not recorded across frame boundary, and that at a frame boundary the frame queue length is enforced by waiting for the last frame in the queue to finish executing, we can then free all command buffers allocated for that frame and reset all associated command pools. Well, yes, you can, but I'm like, why would you want to do that? Well, you can reset command buffer. I mean, once command buffer has finished executing, you want to start to re-record them. You want to reuse them. For which you need to do some kind of reset. I should be able to find that back in my code. So here the command buffer is being submitted, and then where is it being reset? I think I just drop it. This is my synchronization. Here we wait literally for all command buffers to be completed. Well, all the command buffers, yeah, assuming there's multiple, and in this case we have only one, right? It's kind of, I think, a remnant of having two command buffers, one separately for IMG. And then later I just add IMG to the current command buffer, so now only have one. So let's read this as m command buffer completed. Then that means, of course, this command buffer. And well, there's something else here. Reset fences. Oh, this is just the fences being reset. So here we wait for the command buffer to be completed, and then I reset the fence that we were waiting for. At any rate, I don't see any reset. Let's dive into this function. Wait command buffer completed. This just waits for a fence. Well, until this fence is signaled, the command bar is still in use. So we definitely did not reset it. And then upon return from this function, it's still not reset because we don't reset it here. So the command buffer is not reset here. Then I am resetting just fences. My comments, nothing has changed in my command buffer. I think this is the reset. Calling begin on the command buffer just resets it, if I remember correctly. So I'm kind of confused why this guy is talking about explicitly freeing everything. Free all command buffers? I mean, they're part of your queue. What was it? Now I've got how he called it. Frame queue, yeah. You don't want to. Well, they even want to reset all the command pools. He wants every frame. He wants to restart from the beginning every frame. Why not just keep the command pools, command buffers around? And he's not explaining it. I don't know. Additionally, instead of freeing command buffers, it's possible to reuse them after calling vk reset command pool. Yeah, or not. I'm not doing that either. I just reuse them. Which would mean that command buffers don't have to be allocated again. Yay. While in theory, allocating command buffers could be cheap, some driver implementations have a measurable overhead associated with command buffer allocation. I think he's not being clear at all. If you would use vk reset command pool, then that also means you need a pool per frame queue or frame resource. Which he's not explaining at all. Some driver implementations have a measurable overhead associated with command. Okay, this also makes sure that the driver doesn't ever need to return command memory to the system, which can make submitting commands into these buffers cheaper. Yeah, I think that the way I do it is already correct. He's being slightly unclear, vague, and inconsistent, and so he's not the authority here. And what I implemented is pretty sure based on feedback from Discord, Vulkan Discord. So depending on frame structure, the setup above may result in unbalanced memory consumption across threads. For example, shadow draw calls typically require less setup and less command memory. When combined with effectively random workload distribution across threads that many job schedulers produce, this can result in all command pools getting sized for the worst case consumption. Oh, right, yeah. I say right, but not really getting it, I think. It looks like that what he means is that you would use a thread-aware allocation library, or maybe VMalloc is doing this already. So if a certain thread is allocating memory, you would get it from a heap that is specific to that thread, which then would only work if you do everything in one go. So a thread just starts with allocating his command buffer. No, we don't do that anymore. It just starts with resetting the pool or whatever, and then recording it. He is using a command. He is using a command pool per thread, I guess. It's all very confusing. I mean, if you have different workloads for different command buffers, but threads are just randomly put onto it, then yes, every thread gets the difficult command buffer every once in a while. But how would that lead to more memory consumption? Well, if you say that you assign a certain command pool to a certain thread, no, it doesn't make any sense. I have no idea what this means. Or maybe I'm assuming that what he finishes with is trivial. To limit the parallelism for each individual pass and select the command buffer pool based on the recorded pass to limit waste. AKA, the pool must be linked to whatever you are recording and not to the thread that is running it. Well, I would definitely already do that. Mine would be linked to the task, and the task is run by multiple threads anyway. So I don't think that's going to be a problem at all for me. This requires introducing the concept of size classes to the command buffer manager. Boys Bunny, I'm glad you like my voice. Command buffer submission. While it's important to record multiple command buffers on multiple threads for efficiency, since state isn't reused across command buffers and there are other scheduling limitations, command buffers need to be reasonably large to make sure the GPU is not idle during command processing. Additionally, each submission has some overhead, both on CPU side and on GPU side. In general, a Vulkan application should target less than 10 submits per frame, with each submit accounting for 0.5 millisecond or more of GPU workload. And less than 100 command buffers per frame. Hmm. So essentially I just want to record as few command buffers as possible, as long as I manage to do it within one frame. And once that starts to fail, I better start to record more than one command buffer. More than one command buffer simply meaning using more than one thread to record the command buffer. And then when it says in general Vulkan application should target less than 10 submits per frame, then that seems to say that I can only record less than 10 command buffers and therefore use only less than 10 threads to record it. I have 32 threads. So if I would use all 32 threads, okay, that's unlikely. Let's say I would use 20 threads, then I'm gonna have 20 submits. But okay, then we have an incredible load by that time. So, well, it's not really a worry yet, I'd say. Oh, wait, no, that's not true, not true. Less than 100 command buffers per frame. Yeah, I can if I have 32 threads recording 32 command buffers, I can just submit them all at once. So definitely as few submits as possible, which is probably just one submit per frame then. Or maybe two, in the case that what he describes here, blah blah blah, it might sense to submit all command buffers for shadow rendering before recording commands for other parts of the frame. Well, I don't really see that, but that would definitely be a case where you do 2 submits in one frame. Crucially, the number of submissions refers to the total number of VK submit info. The number of submissions refers to the total number of VK submit info submitted in all VK submit calls in a frame. Thought that was not true then. It does not refer to the number of VK's queue submit calls. For example, when submitting 10 command buffers, it's much more efficient to use one VK submit info than 10 submits. Sorry. To use one VK submit info that submits 10 command buffers compared to 10 VK submit info structures with one command buffer per each, even if in both cases only one VK submit call is performed. Oh, okay. Well, VK submit info. We have to limit that. I think that's why I was calling it buffers. Alt tab. So command buffers completed means that you can submit multiple command buffers, and we use one fence for all of them, and then the last command buffer contains signals fence, I guess. To execute it in order anyway, then yeah. Getting tired. I'm halfway this article, but I scrolled over a lot. Pipeline barriers. No idea what that is. I definitely need to read that. I already did the random passes. Yep. Fast MSAA resolve. Oh, that's new. But it does have to do with the random pass stuff. Pipeline objects. Yeah, I think I'm gonna stop because it's otherwise too much at once. Now I should go to bed, of course, but yeah, I know myself. I'm not going to bed. Why am I not going to bed? Why am I being such an idiot? I feel like playing a game of Risk instead of going to bed. Sleepy. I should go to bed. Damn it, why am I not going to bed? Every morning I think, tonight I will go to bed sooner. Yeah, okay, fine. Equip now? No. Global domination. No games. This thing is dying. I tell you, it's dying. I'm just going to play auto match. Okay, how about I play against bots? That's maybe fun. Let's play this, and then we play, well, that's probably not even possible. Okay, well, the conquest is not really fun. Just do world domination, because the bots are too bad at... Well, now I'm playing against bots, I must be able to win, right? I'm blue. Bots can be so aggressive, it's no fun. I guess the same rules apply, you just have to try and make them attack each other instead of me. Oh, there I go. They are killing me already. The orders are kind of important. Say I want to play after green, so I want to play in the neighborhood of green. That could be here. Okay, I found an interesting button today. Let's play in the neighborhood of green. And not in the neighborhood of yellow, which is immediately after me. So, can I kill this? And then we just move 5, and then I kill this. And attack, and then I move this to there, because that was the biggest one. Yeah, here's an interesting button. If you click that, it's just being fast. All the AIs have played. It's my turn again. Isn't it wonderful? Okay, now we have a problem. It's standing with 5 next to me. Is it going to attack me or not? I think it's going to... It wants this territory. Bots really want territories. So it wants this territory, but I think it's going to put... So it's going to put stuff here. Then it has 10. 10. It can eat me. And I would be dead. But I think it's going to first attack this one, because it has less armies, and then it's going to put 4 here and 4 here, and I'm still alive. But I do want to need my card, and they already killed me, right? No, it's the only place where I have something left. Oh, here. Next, let's try to get a card like this. Yay, that worked. And attack phase and turn. Well, I'm gonna press the button just to speed things up. We survived it. So what I said happened, you see, it attacked this one. It's now green and there's only 4 left. And well, really the only thing I want is not to be attacked. Let's put 2 here so I have a little bit more chance to get a card. Do I have a set? Do we have a set? Yes, you have a set. Okay, the game is won. So I click continue again, or do I want to see what happens? I want to see green play, but it takes too long. Okay. Orange is getting strong already. But nothing I can do about that, I think. Okay, now I'm going to let's kill it completely. Put 3 here. Put 10 here. No, it's 9 there maybe. That's especially green that is mad, right? Don't you like this? Eight against 9. Oh, 9 against 1. The green is here as well. But I don't think green is being mad at me. It's a bot. Bots don't have emotions. Okay, I'm gonna click the button again. We survived. Isn't that great? Well, let's put something here. I mean, it's soon. Yellow is possibly having a set, so he possibly get 13 here. So but he's every time they take something, they divide evenly. So even if he starts 14, he has 7 here, and then he takes that, and he has 3 or 4 here. This is already safe enough. I'm just going to put everything here. No, I'm not. I'm going to put 2 here. Well, purple could put everything here. Purple does not have a set. Got to be slightly safe. Okay. Oh, see, well, only put that there. Yellow is definitely going for this continent. Let's click on advanced. There we are. So indeed, it ended up with 4 here. Only 4. I think yellow has its hands full to get this. And well, pink is almost dead and has 3 cards. Can we kill pink? Yes, we can kill pink. Let's kill pink. Okay. 8 more cards. Well, this is the point of defense, I guess. And then we did enough. And attack, move it here. Why is killing bots so easy? Oh, orange is getting very strong. Also has 2 continents. And yellow is getting dangerously strong as well. Yellow is afraid that I attack his to be continent, but I don't think it's going to attack me because it just wants this. Only wants this. Nevertheless, we'll increase this a little bit. Let's click this button. What? I lost my continent. Okay, that's pretty horrible. Yeah, I thought, I've been stupid. I thought this was the point of defense. But there is this line as well. Whoopsies. Let's try to get it back. Oh, easy. Okay, and then I'll just have to move my 14 back. It's also 7, right? So make it 12 here, and then I should have put 2 here, but I didn't have time for that now. Okay, yellow still leaving me alone. And we are safe. Still safe. Orange is threatening me a little bit here. A little bit much. But still I'm going to put 4 here just to be sure. And then maybe put the rest here. Okay, let's attack this with put 3 or 4 there. 3, 4. Yeah, that won't work. Need to do something about orange. Orange is too strong. Okay, I'm gonna click the button again. Nothing happened. Easy. I'm just gonna kill orange. Shall I kill purple? Orange went here, so he might go back like this. Don't want that to happen. Let's put this here and then attack. Oh, loads more. Oh, and turn, idiot. I wanted to put those 2 also here. But anyway, I think that he is going this way now because 6 is higher than 3. Okay, I'm going to click here again. Yep, we did. He went this way. Now it's time to kill purple, I think. Oh no, it's only 1 card. It's not interesting. I think it's time to kill orange. Orange is getting way too strong. Do we have a set? Oh, 10. No, let's wait 1. Let's kill purple this time because now purple has 2 cards. Let's wait 1 more time. So I'm gonna put this here. Now I need to kill that. That's a lot. Cannot kill that. Could kill it anyway. Okay, my set goes. Have to kill it. I just have to kill it. Which movie was that? I like the intonation of that. Oh, and now I let green have its continent. This is like taking candy from a kid. Oh, 16. Oh, but it's stupid again. You know, it just wants to have territory, even if it's not going to happen. I need to do something about this as well before he kills my 14. I'm a bit too greedy, I think. I should have like 30 armies here and 30 armies there and do it slow. You cannot take all the other colors at once. Well, I guess it's worth killing purple now. I do get a set if I do that. 9. Oh. Killing purple. There's only one left. Sorry, I want to stand there. Not really, actually. Well, let's put 3 here and then end attack. Put those 3 here. Boss Bunny, you have to say it doesn't really matter if I'm doing C++ or not. You can also listen to my voice while I'm playing Risk. There's nice colors as well. Okay, I really need a new continent here because I'm not having enough armies. And orange is being super annoying. Again, having 2 continents. As if I have nothing else to do than take continents from orange. Oh, it's not connected. That worked, and got to kill green as well. Green got both of its continents back. Seriously. And so did orange. Well, one of them. You cannot have that, green. And orange has again. Really? Come on. I'm having no armies. Almost no armies anymore. 5, 3, 2, 1. There's 11 here. Okay, let's kill this one. Let's kill the sucker. Or not. I think we're winning. Yippee, I'm winning. Let's click the button again. 27. Yeah, okay. Who shall I kill first? Orange or yellow? It has been decided. Yeah. Yeah. Oh, it has no set. Yeah, now I can no longer avoid going to bed. I hate it, but it's true. I'm even going to give this set and just do it. Oh no, it survived. Yeah, click, click. Now it is a sit. What do you think? Is it going to take 1, 2, 3 continents off me, or is it going to be as stupid as always? Expert bot. Oh, it's taking a continent. Well, you could try to take this continent. No, okay. Yeah, that was totally not worth staying up for. Playing against bots is just... yeah. Okay, I'm going to bed. Quit game, yes. Goodbye. Steam, exit. Everyone, good night. That's gonna be 100%. I know it. Well, who doesn't? Yeah. We need to find a solution for this. I think a solution would be to make all houses underground, far away from each other. I mean, that you can play 120 watt music and nobody will hear you. It's really like a bunker underground, so with a lot of sand around it. And then the exit is just, through a staircase or an escalator to the, or an elevator to the surface. And then you get into a city, which has a 24/7 economy. All the shops are open 24/7. And then everyone can just have their own rhythm. You just go to bed when you feel like it, and you get up when you feel like it. It doesn't really matter anymore. I mean, we're connected with the whole world anyway. So I just get up and I talk to people on the internet. There's always people awake, right? I get up, I go to the shop, and I buy my food because the shop is always open. This is how it should be. And then when finally I go to bed, I'm in my underground bunker and it's really dark and totally silent and I can really sleep as long as I want. That's how life should be. Just saying. Good night.